unless you already had it. So then, let's see, let me double check. Okay, so now what I want you guys to do is go down to mixture sample and mass of mixture and small whey boat. You're going to say 15 grams.
Wait, why did we write 15?
15, unless you already had data. So like you already have information written down there.
Yeah, I'll just write it down.
Sounds good. Do whatever floats your boat. Okay, and 5 grams should go here.
I got 2.7.
I'm just throwing out new numbers.
15 grams or 20 grams? Or the mass of the mixture?
I said total, so mass of the mixture and the whey boat is 15 grams. Okay. And then we'll just say that the small whey boat is also 5 grams just for ease of math. Okay, I'm just throwing out new numbers, right? Do you guys remember in one of the first labs that we did, Davidson's just like, oh yeah, I'm just throwing out numbers. Doesn't matter if these are the actual numbers, right? I think it was the density lab. He was just throwing out numbers, right? And we're doing the same sort of thing. So you guys get the concept of it, right? Without actually having to worry about, oh my gosh, I don't know how to use a balance, right? Or we ran out of time. Okay. So yeah, you should have mass of your mixture as how many grams? We know the mass of our total mixture is 15 grams, and then we've got the mass of an empty whey boat is 5 grams. What should we have for just the mixture? 10 grams, right? We've got 15 minus 5, because we're taking away the mass of the whey boat, and we'll have 10 grams left for our mixture. Perfect, guys. Okay, so now we're going to have 3 different totals. Or sorry, we need to get a filter. For filter, you can say that that's 2 grams, right? Mass of our filter is going to be 2 grams. Again, I'm just pulling numbers out. So under the chalk portion, your second line next to the chalk portion should say something like mass of clean filter or mass of empty filter, right? So let's make sure we're paying attention here. Okay, let's see, we've got, oh, that's me. Say it again. Nothing. So the filter one is going to be, oh, sorry, I'm totally catching on things. The filter paper is 2 grams. Okay, so now we got to look at the total of our total 1, 2, and 3. Okay, so totals 1, 2, and 3 is going to be the first line in each of our 3 sections. So for total 1, we'll say that that is, 3 grams. Okay, so our first total for citric acid, the first line on the top right is 3, or sorry, shouldn't be 3 grams.
No, it should be like 8.
It should be 8. Thank you. I'm going backwards here. So the filter should have been this one. Yes. You don't need a 5. You don't need a 5 there. Okay, so 8 grams it should be the first line on the top right. Okay, it goes with the mass of evaporated citric acid and whey boat. Okay, so if we've got 8 grams for the total mass of our evaporated citric acid and our whey boat, how much are we going to have for just the citric acid? We're going to have 3. Yeah, I kind of spoiled that answer earlier, didn't I? I said, oh, it's put 3 grams there. That's because I was thinking of how much the citric acid itself was going to be. Okay, so we've got 8, and then you have the mass of our whey boat, which is 5 grams. And then that means that our citric acid is going to be 3 grams. Again, if you've already got data for that, that's cool. Okay, so for the sugar portion, let's say that that's 10 grams total. So 10 grams for mass of evaporated sugar and whey boat. Okay, how much are we going to say is just sugar? 10 grams for the mass of the sugar and the whey boat. Okay, I'm seeing a lot of fives. Good. We can do subtraction. It's not too early in the morning. We like that. Okay, and so then for our last one, we've got mass of dried chalk and filter paper. Okay, so if we've got chalk and filter paper, let's say it's like 1.5 grams total of chalk. Or sorry, 2.5. I'm doing this backwards again. 2.5 for our mass of chalk and filter paper. And then again, I totally just spoiled how much is going to be just chalk, but what's the answer? We've got 2.5 for 0.5. We're going to have 0.5 of just chalk. Okay. So the next step is to calculate the percent of chalk, the percent of sugar, and the percent of citric acid. So let's see if this will be connected. Yeah, but it won't. I'll just do it from this screen. It'll be fine. Okay, so if we've got percent citric acid. Okay, how do we calculate percentages again? Remember when we did percent of girls in the classroom? We added the totals up and then we divided by maybe the subgroup or something, right? So for citric acid, I'll walk you through this one. We've got how much citric acid, how much should we calculate? 3 grams. Okay. And then how much was our total mixture? Our total mixture was 8 grams? Was it 15 grams? It was 10, right? So remember, to get 10, we started out with 15 grams.
Because 3 plus 5 plus 0.5 doesn't equal 10.
Yeah, I know. We'll cover that. Don't worry. Good catch. But I'll talk about that in about 10 minutes or so. Okay, we got to get through the math part first. Right, so we had 15 grams minus 5 grams, not 10, equaled 10 grams for our total mixture. Okay, so if we do 3 divided by 10, last thing we have to do is multiply by 100%. So pull out some calculators. You can use your phone, but I would recommend using an actual calculator because guess what you can't have on the test? Phones. Okay, so we want to make sure you guys know how to use a physical calculator before the test happens, because believe me, it is no fun trying to learn how to use a calculator on the day of the test. Okay, Shelby, what percentage are we getting for citric acid? 30%. Okay. So we're getting 30% citric acid. So underneath our, what does it say there? Evaluation section, the third line, percent citric acid, you can put 30%. Okay, what if we want to look at percent of chalk? What should my top number be? Vanderlei, what's my first number going to be for chalk? Wait, say it again. From, oh, did you have your own data for the chalk? Okay, sorry. It would be 0.5, right? Again, if you have your own data, use your own data. If you're using the made up data that I've thrown out here, it's 0.5. Okay, and then are we gonna have the same number for our total under here? Are we gonna have 10 grams for our total? Yeah, we're gonna have 10 grams for our total mixture. So I just realized I don't think we covered what the formula 4% composition is. percent composition, I'll just put it here, percent composition is equal to, you know, a part over the whole times 100. Okay, so if we've got part for the citric acid, we're talking about how much citric acid did we measure at the end of this procedure. And then whole is our total mixture. The whole will always stay the same because we're starting with the same mixture each time. Okay, so if we're looking at chalk, we're looking at the same mixture that we started out with. So our evaluation of a percent is going to be looking at the same starting material. It'll be a different part because we're looking at chalk. But again, we're just following this formula here, part over the whole times 100. So what percent does this end up being? 5%?
Yeah.
What did you say? 50%.
0.5, sorry.
Oh, 0.5, yeah.
If the one before, that'd be 5.
Oh, yeah, no, it would 5%.
50,
Yeah, I'm like, whoa, how'd we get 50?
No, I was looking at the other one.
Gotcha. All right, so yeah, let's look at sugar. So for percent of sugar, we're gonna have, what was the mass that we had for sugar? For the made up numbers. 5 grams for sugar. Okay, what was the total mass of our mixture? 10 grams. What's the last step we need to do? Multiply by 100. Okay, then this one does end up being 50%. Okay, so 50% sugar. Helps if I can spell sugar. And then we've got 5% chalk and 30% citric acid. Okay. So now let's look at our first question. Calculate the percent error for sugar. Okay, our sugar, I'll tell you, especially if you have your own data already, our sugar was supposed to be, and this is our accepted value, was supposed to be, I think, 25%. Okay, so someone remind me, did we study percent error last unit?
Yeah.
Just a little bit, just, you know, may have briefly mentioned it. What was the formula for that?
Observed minus accepted. Divided by accepted.
Observed minus accepted over accepted times 100. Right? Did I hear that right from you guys? Okay, yeah. So this is our percent error one that we did. So if we're looking at calculating the percent error for our percent composition, what are we going to do if we've got an accepted value of 25%? What would the 50% be? What it would be the observed, right? So we've got 50% and 25%. So should we put our 50% or 25% first? Do the 50. So we'll do 50% here. And you don't have to put the percent in on this part, I should say. You can just put it as 50 minus 25 over 25. Times 100%. Okay, so what would our percent error be for that one? It'd be 100%. We have 100% error.
Let's go.
Real bad. Okay, so if we've got, and was that a positive or a negative 100%? Positive. Okay, so we've got a positive 100%. Does that mean that we observed more or less than our accepted? We observed more. So if we're looking at how in the world did we have such a bad percent error, right? Let's look at how our procedure may have caused that, okay? And may have also caused us to lose material, okay? if we're looking at our procedure, okay, if we say, all right, let's get a new page here. We put all of our stuff into a funnel, okay, but maybe just for the first part, maybe we lost some of our mixture as we put it into the funnel. Okay, if we lost a little bit of our mixture as we're pouring it in and it goes off to the side, we don't collect it, would that reduce the amount of mixture that we had? Would that reduce the amount of, say, chalk that we saw? Okay, what if we've got another source of error? Maybe we didn't rinse it enough with methanol the first time. Okay, what did methanol rinse out, guys? Rinse out the citric acid. So if we, didn't rinse it enough and we got less citric acid than we were supposed to, where would that citric acid come out then? If we didn't get the citric acid out, yeah, it would come out with the water. Thank you, Eric. If we had, not enough methanol, rinsing out our citric acid, it would come out with the water. So we would say that we had more sugar and less citric acid. So between the two, if we had less methanol versus, maybe losing some when we're putting into the filter, which one do you think would explain having way too much sugar? Not rinsing enough. All right, talk with your partners, see if there's anything else maybe in your procedure that could introduce a couple of errors, right? Not rinsing enough, maybe not getting a good enough mass, right? Talk with your partners for about 5 minutes, okay? And as a hint, if you guys haven't written down your procedure, I would recommend doing that. Go through your procedure, say, okay, where are some places we could have improved? Okay, I'm gonna come around and we'll see how you guys are doing, see what all we need to do. We're talking about sources of error because in your conclusion, the second part of that first question asks you to make statements concerning percent error and sources of error. Okay, so again, talk with your partners. I heard you guys talking for a little bit. That was really good. But want to make sure everyone's got some source of error. Okay, did you just say Shelby ate the chalk?
Yeah.
That
I swear I went on.
I was gonna say, we need to have a talk about lab safety again. Okay, but again, make sure we're writing down sources of error in conclusion number 1. Okay, what could be a source of error? Okay, I just saw another one that's really, really good. What if we didn't wait for the sugar and water to dry? When we take the mass of our weigh boat containing the sugar, what happens if we still have water in it? We're weighing the water too, so we would have a lot more pretend water or pretend sugar, right? Because we're weighing the water as if it's sugar as well. You look confused, Shelby. Everything's confused. Okay. If we've got our weigh boat and we've got some sugar in there, right? But we don't let it dry. So we also have water. And we're impatient, right? I don't want to have to wait to get the water. So I weigh this and I find out that it's 20 grams. Okay, how much was our weigh boat then? That we said it was 5 grams. So our sugar would end up being like 15 grams. Okay, and that would be a huge amount of error. Why did we get so much more mass? Because there's still water. Yeah, it seems kind of silly, like, oh, why am I asking why do we have so much mass when I specifically said there's water in it? But you could say maybe that, hey, we didn't let it dry enough. Okay, I didn't tell you how long I dried my sample for. There could still be water in it. Okay. All right, so again, make sure we've got our procedures written. Okay. Let's talk about number 2 then. Devise a way to separate sand from a mixture of charcoal, sand, and water. Okay, so what it's asking us to do here is to come up with a procedure, kind of like we did for this lab, to separate charcoal, sand, and water. Okay, so let's start with sand, charcoal, and then what was the other one? Water. Okay, what do you think our first step would be? Let the water evaporate. Okay, so if we get rid of the water, all right, step 1, let water evaporate. Okay, if we get rid of the water, we have sand and charcoal. How could we separate the sand and charcoal? Talk with your partners and figure out ways to distinguish between the sand and the charcoal. So You can do it either as a flow chart or as a stepwise thing. Flow chart is very helpful. Okay, but I will be happy with either one. Okay, again, work with your partners. If you're a desk apart from each other or a row apart, span the gap, figure out how to talk to each other. Okay, who wants to be brave and share their process? I know it's a horrible question for first hour. We're all too tired to be brave. Okay, Eric, what was your idea? We heard a really good one.
We would separate.
Oh,
Hi, everyone. It appears that the Wi-Fi is back up. If you want to try reconnecting, and hopefully we'll connect.
woo! All right.
So we would let the water evaporate,
Okay.
and then we would light it on fire because charcoal is flammable and sand is not. So we would apply a heat source and wait for the charcoal to
Burn up.
and float into the air.
Fl-
We would measure the sand. It's just-
Because then that would be all that's left, right? All right. All right. So if we wanted to set on fire. Okay. Again, this is just one example. Okay. The other example that you could do if you wanted to break from our first step, you guys ever put briquettes in water? They float. Okay, charcoal briquettes float. So you can pick out the charcoal because it floats in water. What was our mixture originally? Water, sand, and charcoal. So if we've already got water in there, you can just pick out the charcoal because it floats. You can either, skim it out with like a strainer if it's in a powder, or you can use tongs if it's in a briquette form. Okay. So if we've picked out the charcoal, and what are we left? Or yeah, we've picked out the charcoal. What's left? Water and sand. So we can say, oh, okay, we picked out the charcoal. Now we can evaporate the water. Okay, so either way, these would be good. You could say, oh, let's evaporate the water and set the charcoal on fire. Let's pick out the charcoal and then evaporate the water. Either way, you guys are looking at, different characteristics, physical or chemical, to separate these guys.
So how will we draw that as a flow chart?
So as a flow chart, if you wanted to do it as a flow chart, okay, you could say, yeah, does it evaporate? Right? We can do, okay, H2O evaporates. Yes. Okay, then what could our second question be if we're doing our first set? flammable. Okay, I'm gonna just put fire because I don't want to spell flammable. And yes, what would yes be? Charcoal. And no would be salmon. Yes, that's a N. That looks like a W. That's fine. Okay, so that's one flow chart that you could do. What would a second one be? If we're trying to do the second set of instructions. Yeah, you could do it floats in water. That would be our charcoal. And then we would have our evaporating question, right? Okay, what I want to do now, let's take a step back from our likes to solve like lab. Okay, let's go to the practice homework. Okay, someone remind me, is our practice problems in the back of our book, are those all due as part of the packet? Yeah, okay, so we're gonna do a couple of them to really cement some ideas, okay? So, because I know for sure there's one that you guys haven't been able to do until hopefully now. We'll see how it works. Okay, let's look at number 29. Okay, number 29 on page 13. '29 says draw an apparatus that you could use to separate a mixture of white sand, okay, white sand and sugar. Okay, who here remembers what the word apparatus was? Tools. Okay, what kind of tools? For science tools. Yeah, no, that's exactly what it is. That's exactly what it is. Okay, apparatus, it's that really weird word, right? Makes you want to say hippopotamus instead of apparatus. Okay, apparatus is going to be a set of tools. Okay, what was the apparatus that we used in the lab? Well, we used a ring stand. What else did we use? Funnel thing. Now, are you talking the funnel or the funnel lined with the paper? Both. Okay, so funnel and filter. Helps if I can really spell. It's too early to spell, guys. All right, what else? What's another piece of equipment that we used? Pipettes, that's awesome. And I heard balance. What else do we got? Weigh boats. Weigh stuff, right? We'll put balance under that too. Okay, so this is just some of the apparatus that we could be using. Okay, what this question is asking you to do is to draw or describe how you would use it. Okay, if we've got white sand and sugar, what's a way that we could separate these guys? Blowtorch. No, we don't want to set this stuff on fire. Okay, what did you say? Sugar burns. Sugar burns and sand doesn't. We want to physically separate these guys so you can recover both components. That's a key part of this question. Put water in it. Okay, we've got, put water in it because sugar dissolves and sand doesn't. Okay, how could we use what's listed here to separate our sugar and our sand once we add water? What's up here that could help? Everything we use for the other one. Okay, how would I draw that then? What would my first component need to be? Vanderlei, you got a hand up?
You know those boxes with the mesh in it, but a whole bunch of stuff in it, shake it around and pull the stuff. What would that called?
I think a sieve. Yeah, I would say it's something like a filter too. Okay, if we're adding water to the mixture, right, would we need the sieve or would we need a filter? You could use both. Okay, but I would draw, right, try and draw a little ring stand, right, and then build on that ring stand what you would add. Okay, so maybe if my thought is, oh, maybe I'll add you know, a ring on there, and I'm gonna put a beaker on there. Okay, and I'm gonna set fire to the stuff inside the beaker. Woo, fire, right? You know, take that ring stand and build what you think would work. Losing my voice here. All right, when you're done with 29, make sure that that first page of homework is all done. At this point, you guys should be able to do all of it on that first page. And then if you're done with the first page, you can go on to the second, the third, and just keep on cruising through. We're trying to give you guys this time to finish the homework and ask as many questions as you need. So we're on this one, 29. Okay, and I definitely recommend putting your phone away. Thanks. Question? Yeah, which one do you want to take? Okay. Okay, and also as a little reminder, the fun with elements part, if you do the fun with elements page on page 12, you get 5 extra credit points. Okay, so if you do fun with elements, you'll get 5 extra credit points for doing the whole thing. On page 12. Fun with elements is page 12. Do it all for 5 extra credit points. Okay, but for now, don't do the fun with elements, okay? I would definitely recommend doing the homework part of it. Okay, just as a reminder, you guys can use the periodic table on this homework because guess where else you can use it? You can use it on the test, okay? So if you want to make sure you know how to use your periodic table, use it on the homework, okay? And if you need another periodic table, we've got a couple extra, okay? But you'll have to fill it out on your own time. We can give you the video for that. And I will also say, if you guys want to retake that element quiz, please come into B time. There's still people that have like a 2 out of 50 on that. Yeah, 2 elements out of 50, okay? So if you want to check your grades in between now and B time, I recommend it, okay? And say, oh my gosh, that's me. And come into B time and give it another shot, okay? see kind of a thumbs up, thumbs down, thumbs in the middle. How are we feeling for a test tomorrow? Okay, we've got a lot of these, a couple of these, and a handful of these. So
Can you go back over the density and the melting?
okay.
Yeah.
So I think it might be a good idea. We'll have another big review day of a lot of the periodic trends and some flow charts, okay? So we will test on Wednesday. Okay, now be aware, guys, do we have the same amount of time in class on Wednesdays? No, okay, so we'll have an extra day of review, okay? But if you're okay with it, right, again, raise your hands, all in favor. Okay, we've only got a couple of, okay, most of the people that are voting are getting that, okay? We can do the test on Wednesday, but again, we're taking less time on Wednesday because we have what, like 10 minutes left each class? Okay, are you guys okay sacrificing those 10 minutes? Okay, are you guys gonna be good if we take another day of practice and review? Okay. All right, so what are we gonna do tonight then? We're gonna study so that we can come in tomorrow with all the questions we need for things that we're not understanding still.